Hello, I welcome you back to this online tutorial. Last time we had covered nomenclature of aldehydes, and today we are going to continue from where we stopped. So we continue with nomenclature of ketones. These are some of the examples which I was able to work out on nomenclature of aldehydes. Then I also left behind an easy exercise for a reader where I tasked you to name these organic compounds, which are aldehydes. Hopefully you named them and they were able to come out correctly. So today we start off with ketones, and we want to write down the IUPAC names of the given organic compounds. Do not forget our rules of nomenclature, which we are following. Priority is given to the functional group first. And since I am naming ketones for nomenclature of ketones, don't forget that we replace ANE in the alkane name, the corresponding alkane that gives rise to the parent chain. So we replace that with ONE. Like in this example, I have a compound made up of 3 carbon atoms. So if there are 3 carbon atoms, that is propane. However, since it is a ketone, the name will be propanone. Propanone, that will be its name. Then still here, by the way, here I can also number the carbon atoms. This is 1, 2, 3. From left to right, then I also number from right to left. I assign these positions to identify the least position of the functional group. So here you realize that following both orders, the functional group CO is at position 2. And it will never change. That's why I call it propanone. Otherwise, someone can also call it propan 2 on. Yeah, but I don't mention the 2 because we are always at 2 as the least position. Yeah, that's why I ignore it. Same thing to this. These are 4 carbon atoms. If it were an alkane, it would have been butane. So instead of having butane, since it is a ketone, we shall call it butanone. And also, if you assign positions here, the least position will still be 2. The smallest position will be 2. That's why I don't mention the 2. Another example is this. So these are 1. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we assign positions from the left to right, and then also from the right to the left. You realize that if I assign positions, this position of the functional group here is a 2, the one up, because down I get a 4. And if you compare both positions, 2 is the smallest. And these are 5 carbon atoms. There are 5 carbon atoms, therefore the name will be pentane 2 on, like that. I do the same here. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like that. You realize that in both cases, if I assign positions to the carbon atoms within the parent chain, I get 3 as the smallest position of the functional group. Therefore, this becomes pentane 3 on, pentane 3 on, like that. Here I have a branch. I have a branch, irrespective of the fact that I have a branch, I first look at the position of the functional group. So I assign numbers to the carbon atom that are existing within the parent chain. This is 1, 2, 3, 4. 1, 2, 3, 4. After that, you identify the smallest position of the functional group. So you see here that if I consider this numbering up, the functional group is at 3. However, if I look at the numbering down, the functional group is at 2. So 2 is the smallest. Therefore, I go with that ordering. If I go with that ordering where CO is taking position 2, then at 3 I have a branch, and that is a methyl branch. So without the branch, the name would have been butane. Without the branch, the name would have been butane 2-on. Considering the branch, so we have 3 methyl butane 2-on, like that. Then here I have a phenyl group. Irrespective of the fact that I have a phenyl group, which I have to look at as a branch, I first consider the functional group. Assign positions to the carbon atom that are existing within the chain. This is 1, this is 2, 3. 1, 2, 3. After assigning positions, I look at either numberings. The numbering up, if I look at the one up, you realize that CO is taking position 1. Then down from the right to the left, you realize that CO is at position 3. Therefore, we go with the numbering or the ordering up, where CO is taking position 1. And without that branch, without this phenyl group, the name would have been, these are 3 carbon atoms. The name would have been, without the phenyl branch, the name would have been propane 1-on. Considering the branch, which is at position 1, you see, the phenyl group is attached to carbon atom number 1. So considering it, we shall have 1 phenyl propane 1-on. Another example is this. Still, I assign positions. This is 1, 2, 3. 1, 2, 3. Either orderings, either way, you realize that CO is at this position 2. Up here, it is at 2. Also down, it is at 2. Then I look at the branch. So if I look at the ordering up, the branch is attached to carbon atom number 1. If I look at the ordering down, the branch is attached to carbon atom number 3. Therefore, I go with the ordering up. So without the branch, this would have been propane 2-on. Considering the branch, we shall have in the branch, we shall have 1 phenyl propane 2-on, like that. Another example, here I have 2 carbon atoms. This is 1, 2. I also numbered the other way around. This is 1, 2. And I can also call this 1, 2. You look at both orderings. The ordering up is giving CO position 2. The ordering down is giving CO position 1. Therefore, I go with that ordering. The one which is down, where CO is taking the least position of 1. So if I go with that one down, you realize that going with the one down, at 1 and 2, they are branches. They are phenyl branches. Therefore, at 1 and 2, since I have phenyl branches, we shall have 1, 2 diphenyl ethanone. Ethanone, this is a ketone, like that. Then without this double bond, lastly, on this example, without this double bond, it would have been cyclobutane. Concerning the double bond, it is cyclobutanone. So these are some of the few examples which I've been able to work out. And on that note, allow me leave this as an EER, easy exercise to a reader. Kindly work out those simple questions. You name those compounds. And then next time we shall look at something else. So now allow me first stop here.